For this lab, we're going to be creating, each group will create 2 solutions, and we're going to be using our spectrophotometer to measure the absorbance of them. Okay, so the first solution you're going to make is our reference solution. In our reference solution, we're going to use very concentrated Fe3+ and very dilute SCN-. That is so that we can assume that all of the SCN-, because it's such a limiting reagent, is going to be converted into our complex ion. So you're going to take the 0.2 molar Fe3+ and the 0.0002 SCN-. You'll also find these pipettes on your tray, and they are labeled. Okay, so this says 0.002 molar Fe3+. That's not what we're using here. We're going to take our 0.2 molar Fe3+ and our 0.0002 SCN-. And I'm going to take one of my beakers. So what you're going to do is put your pipette inside your little pipette controller. You want to kind of squeeze a little bit on the top. And for your test or your reference solution, we're going to do 5 mils of each of these solutions. So first, make sure you know how much your pipette is. Some of them are 5 and some of them are 10. Okay, so if you look like this one, you can see it says 5 ml right there, and then there are some that say 10 ml. So you want to make sure you know what one you're using. If this one says this one is 5, so if you want the entire thing 5, you fill it all the way up to 0. Okay, so what I'm going to do is fill it right to that line. So you can put your pipette controller, or pipette, excuse me, holding your pipette controller, and then you're going to press this button up until it gets to that 0. Okay, if you go a little over, like I did right here, you can just put that button down a little. Now it's right on the 0, so I can go into my beaker and hold that button down to get it all out, okay? Now you don't need to drain it perfectly. Pipettes are set up so that if there's a little bit left in there, it's fine. What you don't want to do is be overzealous and get your solution all the way up into your pipette holder, because then it will react in there, okay? Because then when you use the next solution, you'll start the reaction inside your holder. So you want to make sure you're not going too much on those pipettes. Okay, so now I'm going to take my SCN-, my 0.0002, and do the same thing. You can squeeze a little bit on that top part. And then I need 5 of this one as well. There's 5. I'll put that in my beaker. Then I'm going to take my glass stirring rod and just stir it a little bit. So that's my reference solution. I will then get a cuvette from my tray. Now your cuvette is going to have 2 ridged sides and 2 not ridged sides, 2 flat sides. You want to always hold your cuvette by the ridged sides, okay, so that your fingerprints aren't kind of hurting your absorbance. And just to make sure, you can always use a Kim wipe to wipe it down, okay? So what you're going to do is fill up your cuvette. It doesn't need to be to the very top, but you want to make sure you have enough in it to cover it through the machine. And then you come here and you're going to place it in the spectrophotometer. Now you'll notice the little light symbol and the arrow, you want to make sure your non-ridged parts are there, okay? Because we don't want the ridges to mess with our absorbance. So when you put your cuvette in here, and I'll set this all up for you, you throw it in there so your non-ridged sides are near that light, and then it will give you an absorbance. And it's on my computer, so you can't see it right now, but it will be there, and it will calculate it for you. So then you can go ahead and take that out, and you can put your beaker aside, and now you're going to do your test solution. For your test solution, you're using 0.002 molar of each of Fe3+ and SCN-. Okay, so that's where the other ones come into play. Each group is going to have a different test. So like some of you will do 8 of one and 2 of the other. Some of you will do 4 of one and 6 of the other. I will give you a different reference. So here we have the 0.002 molar of SCN- for your pipette. So I'm going to put that one in, and I'm going to just do 2 of this and 8 of the iron. So what you need to be careful of now, because we're not just doing 5 and 5, is that you're measuring this correctly. So you'll notice on the bottom, like if I want 2 is all the way up here. Obviously that's not 2 milliliters, right? So what you need to be careful of is that you're measuring from the tip up. And so it's almost like this pipette is a 10 mil pipette. So it's almost like you take the number that's here and you subtract it for the total number. So if our total number is 10 and I want 2, I would fill it up to 8. Okay, so you can think of it that way. And obviously that makes more sense. This looks like 2 mils, this does not. Okay, so I would fill it up to 8 to get my 2 mils. So I'm going to go ahead and do that. Okay, I'm going to put it in my second beaker, which has water in it, but yours won't. So there's my 2. And then I'm going to get my 0.002 Fe3+. And I'm going to take 8 mils of this. So this is a 5. This is a 5 mil pipette. So make sure you're checking that. So for the first one, I can go right up to that 0. I'm not getting enough. So if you see that your liquid is getting stuck, you can just squeeze the top a little bit. Like if you're not getting enough in, just squeeze the top. Okay, so that's going to be our 5. But we want a total of 8. So I'm going to, again, we need 3 more. So I'll fill it up to the 2, because you want to take whatever your total is, in this case it's 5, and subtract the number on here to get the number you want. So if I want 3 mils, I'm going to go up to the 2. Whoa, that was perfect. And then you can just take your 4 pipettes and put them off to the side. I'm going to stir it real quick again. So I'm going to rinse it off. And then take my second cuvette. Kim wipe it just to be sure. Fill that up. And put it back in the spec with the non-ridged sides pointing toward the lamp and the arrow. Okay, and that's all we're going to do for the actual lab, and then we're going to use Beer's law to do some calculations.